Hi, my name is Vahan Davodian. I'm a physical experimentalist for 30 years. About 2 months ago, I have uploaded 10 theories to YouTube. They are as follows. Free-falling object by Vahan Davodian, attraction or gravity by Vahan Davodian, Earth's electric field, gravity the cause of attraction, positive and negative charges, the theory of separation of charges, Earth's rotation in Religious University with Dr. Gray, new concept in DC motors by Vahan Davodian. Well, of course, this one is an invention. I have to explain this later. Radiometer, further analysis by Vahan Davodian. Kepler's second law compared with pendulum on Earth. I don't know what happened, but this was amazing. It was year 2005. I was preparing for the lecture in a university, Religious University. I had to consider so many facts, get all the tools for the pendulum because it was a huge classroom, so I had to demonstrate the air and then Earth rotation. And I remember all of a sudden, as I was preparing for those things, and then all of a sudden I remember Copernicus. I don't know that was coincidence or what, but that is a great scientist. I remember his life was amazing. He was the only one, almost 500 years ago, he came up with the idea that the Earth-centered universe is wrong, and then it was amazing. At that time there was no paper anyway. It could have been, Moses' skin or something on a piece of paper or something like that. He switched the Earth and the Sun and solved the problem. And after that they realized, Kepler came and so, they realized that the orbit they had, it was circular, it's not going to work. And then finally Kepler solved that problem. And then I remember I watched almost NASA all my life. I would say the universe, probably every night I watched 2-3 hours of universe, every night. And then when I compared our space station, and imagine how genius some people are. How could they foresee somebody like, Kepler? It was just, he had barely any, telescope or anything. How could they foresee 100 years after, ahead of time? And now when I saw a space station in 90 minutes is going around the Earth, I said, well, wow, this is Kepler's law. And then the other one is 300, and the other one, GPS global position is the system, is 20,000, it goes a little bit longer, and then we got the 42,000, and we got the high altitude 38,000. And when you compare, you can tell Earth is going, the space station is like a Mercury, and the other one is like Venus, and this one is like Mars, and the other one all the way is like a Neptune. So how could they foresee all these things? And because I read the history of science all my life, I remember one of the greatest experimentalists was Sir Isaac Newton, and he was probably the genius. We have never seen such a good scientist in our life. He never ever conducted the cannonball around the Earth. But how could he visualize that if he had a cannonball, it's going to go around the Earth? And imagine so many years past, 100 or even 180 years past, then Mr. John Mitchell came over. He was a geologist. The poor guy died. He could not do anything. Then Henry Cavendish came over. He did the torsion thing. Then they worked. They realized Sir Isaac Newton was right. And he never ever conducted that, the big ball is attracting the small ball. Well, of course, I will show you, because I'm hoping next week I will have my general relativity, and then I will explain the torsion balance, how important that was, because Henry Cavendish was amazing experimentalist, and imagine the big lead ball attracted the smaller one 4.2 millimeters, which in science is light year. It's a law. Anyway, I will explain it. And now I have to explain exactly how these things work. See, the theory of how to replicate Kepler's second law on Earth by pendulum, proportionality of semi-major axes of Mars and Mercury, and their square roots compared with 2 pi 180 of pendulum. Whenever I am comparing pendulum with perihelion and aphelion, I can see the similarities are shocking. You see, this is a big swing by pendulum, and this is a big swing by the planet. And this is the small swing when I compare this. And then I realized they are exactly the same. They are exactly the same because all my life I worked with laws of physics. How did I know they're exactly the same? See, look at here. If I replace the Mars, if I replace the Earth with the spacecraft, same thing is going to happen. Well, of course, the spacecraft is not going in that big orbit anyway, but please pay attention. This is something amazing happening here. It's a conversion of gravitational potential energy to kinetic energy, and from kinetic energy to gravitational potential energy. When I was so young, I was saying, well, how could the planet knows when it goes close to the sun, goes faster, and then further goes? And that is amazing, how the universe is fine-tuned for these things. Probably humans has nothing to do. If I drop a ball from 100 meters, I mean, the gravity is not even there. The only thing which is propelling that, ball or, whatever that steel ball is the gained kinetic energy. If I have 100 meters, then I drop 50 meters, and then it's exactly half. We got half. We got half kinetic energy, then we got half gravitational potential energy. But how fine-tuned it is. As the ball descent goes down all the way, the proportionality is 100%. The amount is losing on the kinetic energy is gaining by gravitational potential energy. But pendulum probably was one of the greatest ideas of the human, and like I said, everything was by accident. And why some people are so observant, and God knows, in Italy millions of people went to the church and they had no idea why the chandelier is going back and forth. But Galileo was genius. I mean, he was not ordinary person. And then imagine, there was no clock, there was nothing. He was so genius. He was 2 years in medical school. Anyway, he saw that, chandelier is going back and forth. He went home, he solved the problem. He got the most important thing in the history of mankind. It's a harmonic oscillator. And imagine, it's a mechanical harmonic oscillator. Without the pendulum, we could not live. And then, of course, in my age, we had the electronic one. It's called tank circuit. It's a conversion of, it's just discharging, charging a capacitor to inductor and so and so. But imagine, in every aspect in our life, we have used the pendulum. Anyway, and then when I compare this, I realize it's exactly here has the most gravitational potential energy. By the time it gets to the center, it's exactly kinetic energy. And the conversion happens so good. I mean, we cannot mess with the nature. It just happened. But how it happened, we don't know. Always I have seen in my life, proportionality is so important. I remember at Regis University there was a student so smart. He was having a problem with proportionality. I said, come over. We had to sit down like 45 minutes. I said, explain. I said, think about the electromagnetic wave. We have the radio all the way to X-ray, all the way to gamma ray. And they said, yeah, you're right. I said, well, that's exactly what happened. If you squeeze one side, then the other side is going to be expanded. If you expand one side, the other side, I mean, there is no way that you can do that anyway, because always the proportionality is there. And then I'm glad he learned, because he said, now I know why gamma ray is so important and is so killer. I said, yeah, because it's got more energy. But the radio wave is not going to kill you because of the wavelength. So, I mean, in science they call it trade-off. There is no way you can gain something but not to lose something else. It's always a trade-off. Like, kinetic energy, back and forth, back and forth. Always they convert from one energy to the other. But the important fact about the humans is, unfortunately, we humans cannot do any experiment thermodynamically closed because it's so expensive. Like my pendulum practically should have been vacuum, but I'm not going to spend $100,000 for vacuum. I have air friction, I have friction with my ball bearings, with the wire, and every time the ball is going back and forth is doing some work. And if you notice, always it's getting smaller and smaller and smaller. So that's why we have no perpetual motion, because always we have to renew the energy. Because whenever we have a motion, the laws of thermodynamics immediately comes in and then is preventing. Anyway, and this is amazing scientist. I like to talk about that how I compared his ideas. He was French. His name was Louis de Broglie. He was the only scientist lived 94 years almost. He was an amazing person. He was friends with almost Albert Einstein and the other guys. And when I was doing my pendulum, it was a small version of Mr. Leon Foucault, and then guess what? It went all the way 165 degrees, but Mr. Foucault went all the way 360 because of gain kinetic energy. It was a huge, not only the bulb was so low, mine was only 2 meters, but his was better anyway. So this is exactly what Mr. de Broglie said. And then, he had a good ideas about the charged particles and the electrons. And in fact, he was an extremely brave person. There was always a controversy with Niels Bohr and then his best friend, Werner Heisenberg. They were just confusing people. This is particle, this is wave. This is particle, this is wave. And I remember one time, Werner Heisenberg was so outspoken. He said, well, I did find something. It's not charge, it's not particle. And they told him, just shut up. It can't be anything. It must be charges or particles. Anyway, Mr. Louis de Broglie said he was sick and tired of this controversy. And you know what he said? Charges are particle, particles are charge. And I don't know why it became a law. So this is exactly what he says. He's got a formula for the electron, but I have to explain what happened. When the electron gets close to the nucleus, my imagination was so good at that time. I said, Rohan, why didn't you get this one exactly like Copernicus, change the Earth and Sun? So instead of nucleus, I can change the electron and nucleus, and that worked. And Mr. Louis de Broglie said, when electron is getting closer to the nucleus, it's getting faster. I said, that is a genius idea. That's exactly what Mr. Kepler said. This is what it says. Well, of course, it's lambda, h divided by p. Well, h was the formula for the Max Planck, and the p is the momentum. And that's what it says. It's a shocking similarities between electrons' kinetic energy. This energy increases as, therefore, according to de Broglie equation, it is increases as the electron's wavelength get smaller. The more electron waves pulls itself into small nodes close the nucleus, the greater its kinetic energy. Well, why did I understand this perfectly? Because I realized it's exactly like electromagnetic wave. Because Maxwell, probably after the Sir Isaac Newton was the best scientist, I would say. What Maxwell did, it changed our life. Even Albert Einstein was not like Maxwell. He was something else. Maxwell said electromagnetic wave is always proportionality. Wavelength increases and the other one decreases. And then if the wavelength is decreasing, the other one is increasing. But you know, always the proportionality comes in a comes in an equation. Anyway, then I realized if I want to do something like this, I have to be able to prove it. But you know what? There was a problem at the beginning because I said, well, Juan, the problem is you are dealing with 180 degrees, but Kepler is, 360 degrees. Well, of course, not even 360 because ellipses. I said, it's okay. But you know what? If I have imaginary line, like a thread or rope or whatever, it's just hypothetical experiment. If I have an imaginary rope from sun to the earth, that's exactly what's going to happen. So we can replace Mars with the spacecraft. Once the spacecraft behaves like a tiny planet when it goes outside its gravity and orbits the sun, not all orbits are circular. The orbits of some spacecrafts are elliptical, so their altitude vary up and down once per orbit. At apogee, its greatest distance from the Earth center, the spacecraft travels relatively slowly because it has converted some of its kinetic energy into the gravitational energy. At perigee, the smallest distance from the Earth center, the spacecraft travels relatively rapidly because it has converted some of its gravitational potential energy into kinetic energy. But to be honest with you, I compared all these. I said, you know what? All of them, they do make sense. I mean, how could you expect Mars go around the sun and then they keep up the same speed, and imagine there is no rope in between, it's just the gravity or whatever, and that is what happened. And Kepler says that each planet travels around the sun in a path that is an ellipse. The sun is off-center, well, of course, inside the ellipse, so that the planets inside from the sun changes as it orbits. The speed of the planet's orbit depends on its distance from the sun. Closer is faster and farther is slower. Planet sweeps out equal areas of its ellipse in equal interval of time. Those eccentric ellipses, an ellipse is not oval. An ellipse has a two fixed point inside called foci, which is the plural for focus. The flatter the ellipse, the greater the difference in length between its major and minor axis, and greater the eccentricity. Anyway, and then I had to do my own idea. I said, Wahan, you be in geometry, trigonometry, you know all these laws of physics. Why don't I squeeze a circle? And guess what? I squeezed the circle. With my surprise, that was exactly elliptical. There was not even 1 micrometer more or less. What I will show you in it. And then this one, let me see if I have it over here. I have to turn the camera a little bit this way so we can see this, because sometimes, you know, this screen is too big, it doesn't show that much. Okay. See, the old days, it was like this. And you know what? Even Kepler itself, they got concentric lines. I said, I don't expect from Kepler. He was genius. But you know, if you remember, Kepler made something which was, I don't remember what they call it. It was, you know, half-cut globe, and inside the globe was the planets. And they came up with all these ideas. You can see those are the stars, and Sol means sun, then Earth, and then Copernicus said, these are all concentric. And then Kepler came and said, no, it must be elliptical. And last night I found a problem. I said, no way. The reason why they changed it, because they didn't know why, because there is no way, if the concentric line, it doesn't matter how they move, they are going to coincide with each other. But the elliptical, no, they are free to leave, and that's the reason why they have kinetic energy. And this is another one, and then like I said a few minutes ago, and see there's a spacecraft here, and then you can see there's a spacecraft here, Apogee, Perigee, and then I realized, what if I squeeze these smaller and make this narrower, and it worked perfectly. It works so perfectly. Now I'm going to have to go ahead and turn my camera a little bit this way so you can see what I mean by that. Because this was genius idea. Let me see if I can bring my camera close. So you see this? This is the one I devised because the reason why they were having problem with the, let me show you how. They were having problem. Let me see what happened. Okay. They were having problem. Why? That big, triangle becomes narrow. So I solved this problem. But I show you how. You see this aphelion? When it goes, you see here, it's round, but here is flat. By the time it gets here, look what happened. Did you see what happened? It's cutting off this part. And this was genius idea. I remember I had a friend from Caltech. He loved this idea. And this one, perihelion, is the same way. This comes here, is a smaller. By the time it gets here, it's getting stretched, getting stretched. See? And then I just compared this with red shift and blue shift. I realized it's exactly the same. Look, see? Red shift, blue shift, red shift, blue shift. Well, of course, I don't want to go through the formulas and so, but always in my experiment, 99% of the time, I have used electromagnetic wave as a frame of reference. And then when I saw this, they did understand perfectly what it was. And then there was another student, he was having problems with Kepler. Let me see where the Doppler is, right there. Okay. And this was another genius idea. I show you why. See, the Lexus is there. Enter. And then I always remember when I have my experiment in science, always I have as much as possible, experiment, and sometimes you have to conceptualize what do we mean by red shift, blue shift, what do we mean by Doppler effect, because Christian Doppler was genius anyway. Then they discovered this. But imagine when I move this, the Lexus, Tesla, see, when I move, see, that part is getting squished, this part is getting stretched. And the proportionality is 100%. There is no way that, you can stretch this side and the other side is affected. The reason why determining value is this Tesla. Tesla is going, then it's stretching on one side and squeezing on the other side. See? Stretching, squeezing, stretching, squeezing. And in fact, this, concept is so important that, Edwin Hubble and the other guys in astronomy, they knew that, our universe is expanding. How could you know that? It's because of this. So always in my experiment, I try to get as much as possible, as much as possible, oh, this is the one I have to show you. I'm sorry. This is the one I have to show you. This is the one a few minutes ago I was. Okay, see? If you squeeze a circle, it's going to be oval. And the amazing thing is proportionality. I discovered not only is for the gaining kinetic energy and losing kinetic energy and gaining gravitational potential energy. If you make something flat, this is called semi-major axis, and this one is called minor axis. Can you believe? You can make a box smaller. One side is getting bigger and the other side is getting smaller. How genius is that? How genius is that? It is possible. Because, see what happened? Let me see if I have that photo. Let me see where they are. Those, yeah. Let me see. Well, lab is not big lab anyway. Okay, so anyway, that's what it says. That it doesn't matter if I apply pressure from this side, or from that side and that side, and imagine what will happen. The minor axis is going to get 10 centimeter, and this one is going to get 11 centimeter. This is going to get 11 centimeter, 10, and that one. See what I mean? It's exactly, well, of course we cannot measure nanometer anyway, but micrometer, if you do that, everything is the same. And I also did, let me see what else do I have here. Oh, this is another one. I have to show you how this one works. So this was another great idea. I said, well, we have the elliptical ellipses, we have the Earth, we have the Sun, we have the perihelion and aphelion. I said, what if I go ahead and overlap two pendulums? See, this is a small, 25 centimeter, this is 100 centimeters. See, you overlap, you see the amount of swing, see how smaller that is? I said, what if I go ahead and do that? Everything is going to be the same. And then I realized it's exactly the same. If you, any pendulum you do is exactly acting like a planet. And in fact, I did one experiment. Probably the scientists won't even like this idea anyway, because they said, who the hell is this guy is disagreeing with Albert Einstein? I have seen in TV universe so many times that Mercury has weird, eccentric orbits. Well, of course, I wouldn't say it's 100% circular, almost, but it's not as good as Earth and Mars anyway. And then I remember in year 2005 when I was demonstrating for Caltech for a student, I realized that I solved the problem. Because whenever I had steel balls, it was suspended from the ceiling, it was rotating counterclockwise in northern hemisphere, and it's going to be clockwise in southern hemisphere. And then I had laser beam. I realized that that ball was 155 milligrams. It was going a little bit back and forth, back and forth. I realized it's exactly what it is. And then in my classroom, when I did that for my, not my student, I mean for the other student, they realized that, you know what, whenever the pendulum, I had one like 1 kilogram bob, 1 kilogram is a lot. And then it was going back and forth and back and forth. It would take exactly like 165 degrees rotation, which is good for a small class anyway. And then I realized that after a while, it's getting closer to the center of the Earth. And imagine even 10 centimeters, even 1 centimeter closer to the Earth, it was acting exactly like ovals, but sharp ovals. And then I came to this conclusion, that's the reason why the Mercury is so weird, because it's so close. Well, of course, the sun is not going to crash the sun, but imagine, it is just escaping, coming back, escaping, coming back. But see, Venus is not doing that. Earth is not doing that, because practically they are what? Elliptical. And then, let's see, what else do I have here? I think that is all. And then I'd like to thank some of the professors, you know, and there's so many distinguished people like Dr. Michio Kaku. He's from New York City, and he's my favorite scientist. I know him maybe for 40 years, and then I remember he was talking about, you know, teleportation, and then he was talking about Are We Alone? I read those books. They are so scientific. They're so comprehensive. I like that. I mean, his explanations is beyond my imagination. They're so good. Thank you, Mr. Michio Kaku. You were talking about teleportation, and then I remember that old theory is called entanglement. It is possible. When I was so young, I was so amazed. What the heck is modem, modulator, demodulator? Now I know it's the same thing. Now same thing happened. When I was so baby, I had no idea. One day is like 21st century, we will have a FaceTime. I FaceTime my friend in Australia. I said, wow, this is almost like teleportation, almost. So anyway, and then also there's another physicist, his name is Dr. Nick Lucid. He's fantastic, he's good, his explanation. Dr. Derek Mueller, and physics girls, her name is Diana Cowan. She is also good. And Mr. Arvin Ash is also good. And there's another called, his name is Professor Dave. I just wanted to thank them. And then my email is exactly my name, vahandavudyan@aol.com. And like I said, you can email me. I'd like to get in touch with you guys. This is the way we have to promote the science. We are not here to make money. We are not here to get publicity or something like that. Our main objective is to promote the science.